Welcome back, friends. In video 1, we explained why SOMEIP exists. In video 2, we covered the transport layer. Now we go deep on SOMEIP itself, the protocol that makes service-oriented vehicle possible.
Imagine you are writing a firmware for an ADAS ECU. You need radar object 200 frames per second right now. You know exactly what data you need. You have the service ID, you have the interface definition, but you don't know which ECU on this network has that service. You don't know its IP address and you don't know which port it is listening on. In a canvas world, this problem doesn't exist. Everything broadcasted to everyone. You just filter what you need. But in an automotive Ethernet vehicle with 150 ECUs generating gigabytes of data, broadcasting everything to everyone is impossible. So, how does your ADAS ECU finds the radar service at runtime on a network it has never seen before without any hard-coded IP addresses? The SOMEIP is the answer. And understanding it is the difference between a junior embedded engineer and a senior one. SOMEIP is an automotive middleware protocol standardized through AUTOSAR. It sits at the application layer, seventh layer, on the top of TCP and UDP, which sits on top of IP, which sits on top of automotive Ethernet. SOMEIP solves a specific problem that TCP/IP alone cannot solve. TCP/IP can send data between two known IP addresses, but it cannot answer the question which IP address is offering a specific service. Imagine you are the ADAS ECU powering up for the first time. You need radar object data. You know the service ID that you need, but you don't know which ECU has that service or what IP address it is at this moment. SOMEIP solved this problem through a mechanism called service discovery. But before we get to discovery, let's understand three communication patterns SOMEIP offers. SOMEIP defines three ways for ECU communication. Method call. This is a request and response. One ECU calls a method to another ECU and wait for the result. Example, the diagnostics tester requests the current software version from the gateway ECU. The gateway receives the request and responds with the version string. This pattern always uses TCP because the caller must know whether the method succeeds or fails. If the response is lost, the entire call must be redo from the start. Second one is event notification. This is the publisher and subscriber method. One ECU publishes the data continuously, other ECU subscribes to receive it. Example, the radar ECU published an object detects data 200 times per second. The ADAS ECU subscribes and receives every frame. This pattern uses UDP because if one frame is lost, the next one arriving in 5 milliseconds anyways. Latency matters more than reliability for the sensor data streaming. And next one is field. A field is a combination of both. It has a getter, setter, and a notifier. Example, a vehicle speed field. Any ECU can read the current speed with a getter. A speed limiter ECU can set the target speed with a setter. Any ECU can subscribe to notification when speed changes. Field can use either TCP or UDP depending upon whether reliability or speed is more important for that specific data. Now let's see the SOMEIP message format. Every SOMEIP message has the 16-bit header regardless of communication pattern. Let me walk you through each field. This is exactly what interviewer asks. First one, service ID 2 bytes. Identifies which service this message belongs to. Every service in a vehicle has a unique 16-bit service ID defined in the ARXML configuration. Method ID or event ID 2 bytes. For method calls, this identifies which specific method is being called. For events, this identifies which specific event is being sent. Method ID and event IDs are defined in the same ARXML file. Length 4 bytes. The total length of the message in bytes including the header from this field onwards. client ID 2 bytes identifies which ECU sends this request. The server uses this to route the response back to the correct client when multiple ECUs are calling the same service simultaneously. Session ID 2 bytes. A sequential counter that match a request to its response. The server copy the session ID from the request into the response. This is how the client know which request each response belongs to. Protocol version 1 byte, always 1 for the current SOMEIP implementation. Interface version 1 byte. The version of the specific service interface allows newer and older service implementation to coexist on a network. Message type 1 byte. This field defines what kind of SOMEIP message this is. 0 is a request. The client wants a response. 1 is a request, no return. Fire and forget, no response expected. 2 is a notification, an event being published. 80 is a response, the server replies to the request. 81 is an error, the server encounter a problem. Return code 1 byte, only use in response. 0 means success, non-zero value indicates a specific error condition. Now, here is a question every automotive engineer should be able to answer. Why did OEM with 30 years of canvas experience decided to replace it with something completely different? And the answer is not bandwidth alone, it is flexibility. In a canvas vehicle, every signal is defined at design time. The vehicle speed signal has a specific CAN ID. Every ECU that needs it know that ID in advance. This is written into every ECU before the vehicle leaves the factory. Now imagine Tesla want to add a new driver assistance feature over the air. The feature needs a new signal from the radar. In a canvas world, you cannot do that without updating every ECU that interacts with that radar. You are pushing a software update to 30 ECUs to add one feature. SOMEIP make this problem disappear. Services are discovered at runtime. The new ADAS feature power up, speeds, and finds service message, and the radar responds with its address. No factory programming, no ECU wide update. The feature works for the first reboot only. This is why the software defined vehicle is impossible without SOMEIP. Over the air update, feature subscription, remote diagnostic, all of it depends on runtime service discovery. If you understand this, you understand why new vehicle platform from 2020 onwards is built on SOMEIP. Now let's see a complete SOMEIP interaction in real world vehicle. The instrument cluster want to display the current driving mode selected by the driver. Steps. First one, the vehicle dynamic ECU powers up. It registers a service with service ID 1234. This service offers a driving mode field and a driving mode changed event. In the next step, the instrument cluster will power up. It sends a SOMEIP service discovery, find service message looking for service ID 1234. Then, the vehicle dynamic ECU responds with a offer service message containing its IP address and port number. After that, the instrument cluster sends a subscribe event group message to subscribe to the driving mode changed event. The vehicle dynamic sends a subscribe event group acknowledgement confirming the subscription. And then every time the driver changes the driving mode, the vehicle dynamic ECU publishes a notification event. The instrument cluster receive it and update the display accordingly. If the instrument cluster want to read the current mode without waiting for a change, it sends a get method call. The vehicle dynamic ECU responds immediately with the current value. This entire sequence happens automatically every time the vehicle powers up. No hard-coded IP address, no pre-configuration routing table. The network is self-organized. Now we have reached to the interview section. Let's discuss few of the important interview questions and answer. First one is, what is SOMEIP and where does it sit in the protocol stack? And the answer is, SOMEIP is a middleware protocol standardized by AUTOSAR for service-oriented communication in automotive Ethernet networks. It sits at layer 7, the application layer on the top of TCP or UDP, which sits on the top of IP and Automotive Ethernet. It enables ECU to offer and consume service without knowing each other's IP address in advance. The next important question is, what are the three communication patterns in SOMEIP? And the answer is method call for request and response communication using TCP. Event for publishing and subscribing streaming data using UDP. Field, which combine to getter, setter, and notifier into a single service element and can use either TCP or UDP. And the next question is, why does SOMEIP uses UDP for event but TCP for methods? And the answer is simple. Events are high frequency data streaming where a loss of frame is recovered by the next one arriving in milliseconds later. Low latency matters more than the guaranteed delivery. Methods requires a configuration response because the caller must know whether the method succeeds or failed. A lost response leaves the caller in an undefined state. So TCP reliability is mandatory here. And the next question is, what is the purpose of session ID field in the SOMEIP header? The session ID is a sequential counter including in every request. The server copies it into the response. This allows a client to match each response to a specific request that triggers it, even when the multiple requests to the same service are outstanding simultaneously. And the last question, what is the difference between SOMEIP and SOMEIP SD? SOMEIP is a communication protocol itself. SOMEIP SD is a service discovery, a separate protocol used to find the service on the network. SOMEIP SD use UDP multicast to address 224, 244, 224, 245 on the port 30490. Without service discovery, ECU would need hardcode IP address for every service they use. So, we learned SOMEIP today. SOMEIP is the foundation of service-oriented communication in modern vehicle. Every software-defined vehicle, every zonal architecture, every OTA update system depends on it. Understanding the three communication pattern, message format, and the difference between SOMEIP and SOMEIP SD is what get you through the interview at Bosch, Continental, BMW-like companies. The free interactive simulator for this video is available at autodevpro.tech. In video 4, we will be covering SOMEIP service discovery in detail, including the offer service, find service, subscribe, event group flow, and how we SOMEIP implement on Linux. Subscribe to our channel and we will see you next time with vSOMEIP. Thanks for watching this video.